is module Engage New York, module 3, lesson 13. This is concept development. So going back to the objective of this lesson, just one of the objectives. Obviously, it's adding and subtracting fractions with mixed numbers, but it's also looking at a fraction and deciding how much space, if you put them together or took them apart, would it be greater, less than, greater than, or equal to 1? So that's the big idea here. So if you had a half and you added 3/4 to it, would you end up with a fraction or a number greater than the 1 or less than 1? You're right. You would end up with a fraction greater than 1. All right, so let's go ahead and solve. Now, you have learned 3 different ways to solve addition and subtraction of fractions with mixed numbers. You have method 1, which is just standard, stack them and do it. You have method 2, turn your mixed number into an improper fraction, then solve. Or you can pull out your whole numbers and just work on your fractional parts. So decide which way works best for you and solve. So with each one of these, what I want you to do is, here's one whole, right? And here is 2/5. 1, 2, 3, 4. So here is 1 and 2/5. But if I subtract 2/3 from that, if I'm going to subtract 2/3 from that, am I going to end up with a fraction less than, greater than, or equal to 1? So think about that for a minute. So if you had 1 and 2/5 and you took 2/3, oh wait, I think I did fifths here. Oh wait, no. 1, 2, 3, 2/3 away from here. Where would my fraction end up? Would it be greater than, less than, or equal to 1? And this is just about thinking about reasonableness of a fraction. So as you're going through this, I just want you to think about this. And I want you to somewhere tell me, using the symbols, if it's less than, greater than, or equal to 1. So then if I start over here and I have 4/10, so 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 4, 5, 6, 7, 8, 9. If I had 4 of these and then I added a third more, would I end up with less than, greater than, or equal to 1? And of course, you're going to solve to find out. So this is just estimating. This is just throwing it out there, going, this is what I think it's going to be based on what I know of fractional, of benchmark fractions. All right, so you decide what method you want to use in order to solve. Are you going to use the standard form? Are you going to turn, or standard form? I guess standard form is just going to work here. Then when you have your mixed number, you can do standard form, pull out the whole, or turn it into a mixed number. You decide. I want to challenge you to do all 3 problems. But before you solve, I want you to just make an estimate. What do you think? Is it going to be less than, greater than, or equal to 1? Come back and check your work. So let's review. So I got 56/90, which is definitely less than 1. And I got 103 over 70, which when I pull 70 out of 70 out, that's a 1, right? That's going to be 1 whole, 33/70. So 1 and 33/70, definitely greater than 1. Then I have 27/40, which is definitely less than 1. All right, our last two problems. All I'm asking you to do is decide if 2 1/3 plus 3 1/5 is greater than, less than, or equal to 6 7/8. And then give me a reason. The same with number 8. Tell me whether you think this side is less than, greater than, or equal to this side. And just give me a reason. Tell me your reasoning. And then come back and check your work. All right, so 7 and 8. So I said this mixed fraction sentence is smaller than 6 plus 7/8 because if you look at it, 2 plus 3 is 5, and then if you have 1/3 plus 1/5, well, both of those even together would be less than 1. So you can't even get higher than 6, and 6 7/8 is almost 7. Then not 4 and 9/10 subtract 1 1/8 is greater than 2 1/2 plus 2 2/7, because if you say 4 subtract 1 is 3, but 9/10 minus 1/8, well, 9/10 is almost a whole number, and you're only subtracting a small fraction of it. Then 2 plus, this is a half, and 2/7 is very small, so you're not even going to get up to 3. So that was my reasoning. So our objective today was, could you reason? Could you use benchmark numbers to assess reasonableness? And this right here is